Okay, on to question 4 from the DEB exams of 2020. So I have to differentiate this here, this function, with respect to x from first principles. So I have to use a specific method. Obviously, to differentiate this might be pretty easy for most of you. So using the first principles, what do I have to use? Well, there's a formula for first principles, and it says I have to do this. I have to say that to get the derivative of this, it's going to be using f of x plus h minus f of x, and that's going to be all over h. But more specifically, this is going to be as the limit of h tends to 0. And this is what I need to know. So what do I have here? Well, I have f of x, it's this stuff here. I need to get f of x plus h. So f of x plus h. That's essentially this function again, but replacing every x by x plus h. So that's going to be 5 minus 3 times x plus h minus 2 times x plus h, all to be squared. So that's going to be 5 minus 3x minus 3h minus 2 times, and let's square out this stuff. It's going to be x squared plus 2xh plus h squared. And I'll multiply in that, so 5 minus 3x minus 3h. Now, I get minus 2x squared minus a 4xh and minus 2h squared. So I have all this stuff here, and I actually don't have any like terms here, so I can't simplify it any more than what I have here already. So now, so far I have f of x plus h and I have f of x. So what am I looking for? Well, I'm going to write this. The limit as h tends to 0 of f of x plus h stuff. So that's all this stuff here. That's 5 minus 3x is 3h minus 2x squared minus 4xh minus 2h squared minus another function, 5 minus 3x minus 2x squared. And that's all going to be divided by h. So again, let's see if we can do some tidying up top. So limit as h goes to 0. So I have a 5, and there's going to be a minus 5, so they're going to go. I have a minus 3x and then a plus 3x, so actually that's also going to go, because the minus by the minus will make that plus. Then I'm going to have a minus 2x squared here, and this minus by this minus will make this a plus 2x squared, so this guy is also going to be gone. So what am I actually left with? So up on top I'm left with minus 3h, a minus 4xh, and a minus 2h squared. Yeah, and that's all over h. Now, since h is common to all of these, I can divide in that h. So h into 3h, so that's going to just be minus 3. That's just going to be minus 4x. And this h into this is going to cancel one of the h's, giving us a minus 2h. So I'm nearly done. I'm down to here, and I have the limit as h goes to 0 of all this stuff. So if the limit of h goes to 0, so what's going to happen is h tends to 0. Well, this stuff here is not affected by h. This stuff's not affected by h. This clearly is. So actually what I have now is when I take this limit, I'm going to have minus 3 minus 4x. The h going to 0 turns this h into 0, which knocks out that term. So I'm done actually now. So actually the derivative of f of x should be minus 3 minus 4x, and we've used the first principles method to do that. Now we're on to part B, and it says you have a curve, and the curve looks something like some cubic curve, some ax plus bx squared plus cx plus d, and it gives you 2 points on the curve first. The 2 points it gives you a turning point first. So a turning point is just something like this or something like this. So the turning point, remember, is where the slope's equal to 0. So essentially it's where the first derivative is equal to 0. And a point of inflection is where it changes from this stuff to this stuff, or vice versa. So something like this point in here. So a point of inflection is actually where the second derivative is equal to 0. Okay, so we need to find these values, these coefficients, a, b, c, and d, the constant at the end, based on this information. The first thing that we can do, well, these are points on the curve, regardless if they're turning points or points of inflection. This is a point on the curve. That means we put in 0 for x, we should get back a 2 for y. So let's just do that first and see what happens. So f of 0 is going to be a times 0 cubed plus b times 0 squared plus c times 0 plus d. If we do all that, we should get back the y coordinate of 2. So we can see that these 0 points will all go, and it will simply leave us with d is equal to 2. So we have our first one here. So once we have that, we can go on to maybe the next point. We can say, what about f of 1? What would that give us? So f of 1, well, of course, we know if we replace all these x's by 1, a times 1 cubed plus b times 1 squared, c times 1 plus d. And of course, we know this is a coordinate on this function. That means when x is 1, y should be minus 1. And we also know actually that d here is 2 from the first part. So let's tidy up this. 1 cubed is just 1, that's 1 squared is just 1. 1 times c is just c, and of course d being plus 2, that's equal to minus 1. Therefore a plus b plus c should be equal to, when this comes across, it becomes a minus 2, minus 3. So there's another equation we can make. Now, using this information we have here in the turning point, the turning point has an x value of 0 and also a slope of 0 at that x value. So let's get the first derivative of this stuff. So let's write down the function again just to be neat about it. So ax cubed plus bx squared plus cx plus d. So let's differentiate this. So that's going to be 3ax squared, 2bx, and this x just drops here, and the constant goes. So I'm down to here. Now what do we know here? Well, that's the first derivative. It gives us slopes. The slope when x is equal to 0 should be 0. Therefore, if I replace x by 0, then it gives me 3 times a0 squared plus 2 times b and 0 and plus c. That should give me a value of 0 or slope of 0 since it's a turning point. This goes, and then we get c simply equal to 0. So far so good. The point of inflection, well, that's where the second derivative is equal to 0. So we have the first derivative done. Let's get the second derivative. 6ax plus 2b. So that's our second derivative. What happens here? Well, it says the x value for the second derivative, where the second derivative should be 0, is 1. That means we replace this x by 1, we should be able to set it equal to 0. So we'll do that. 6a times 1 plus 2b should be equal to 0. So that's going to give us 6a plus 2b is equal to 0. So I have this equation now as well. So what do we have? Well, we know what d is equal to, we know what c is equal to, and we have these two equations with multiple variables in it. But let's look at this equation here actually. We actually know that c here should go to 0. So actually I can write this equation I have here underneath and disregard the c now, which I know should be 0. So I can say this, a plus b is equal to minus 3. And of course now we have a simultaneous equation. So what I'm going to do is I'm going to multiply this line here by minus 2. And I'll maybe write it over here, these two lines. So again, the top line is still going to be 6a plus 2b is equal to 0. But now the bottom line, everything's multiplied by minus 2. That's give us minus 2a minus 2b, and minus 2 of minus 3 gives us a plus 6. To solve these simultaneously, this goes 6a minus 2a is 4a, a 0 and then a 6, so it's just going to be 6. So A is actually equal to 6 over 4, which is 3 over 2. So I have D, I have C, I have A. What will I do now? Well, I'm missing B. Well, if we look at any of these equations, even say this simplest looking one here, which is this one here, we can just say A plus B is equal to minus 3, but we know A to be 3 over 2. So 3 over 2 plus B is equal to A minus 3. And solve this. That's the same as multiplying everything by 2 to get rid of that fraction. 3 plus 2B is equal to minus 6. Therefore 2B is equal to minus 6 and a minus 3. That's minus 9. Remember, when he comes across, he becomes minus. So B is equal to minus 9 divided by 2. So we look at all that, then we have our A is here. So sorry for squeezing it in here. A is equal to 3 over 2. B is equal to minus 9 over 2. C is equal to 0. And D was equal to 2 at the very start. That's that part. So on to the last part of question 4, and it says, hence find the other coordinates for the other turning point. So we figured out the values from the part 1 of B. So let's actually put those in and see what the function actually looks like. So A was 3 over 2 x cubed, and B was minus 9 over 2 and an x squared. C was 0, so we have no x term, and D was 2. So how do we get turning points? Well, remember in the first part of the equation we said turning points happen when the first derivative is equal to 0. That means we're going to have to differentiate this guy and set him equal to 0 and then solve for x. So let's differentiate him. So 3 comes down in front, 3 times 3 over 2, and that's now with an x squared. 2 comes down in front, that's minus 2 times, and that's 9 over 2. It's regular x. We differentiate a constant, it goes to 0. So a small bit of tidying up here. We're still with the first derivative. That's going to be 9 over 2 x squared, and these two cancel, give us a minus 9x. So when you set this equal to 0, now it's just a regular old quadratic equation, which we'll have two solutions for. So how do we solve this with no constant? Well, just factor out an x. So we'll get this x 9 over 2, then x minus 9. So these are our two factors. The only way for this to be true is either x is equal to 0 or all this stuff is equal to 0. So either x is equal to 0 or 9 over 2x minus 9 is equal to 0. We have to do a little bit more work on this one. 9 comes over, becomes a plus 9. Now 9 over 2x is equal to 9. So we could, I suppose by cross multiplication we could bring the 2 up and the 9 down, or we can multiply everything by 2 and then divide by 9. Do whatever way I want, but how I would do it is probably multiply this by 2, that's 2 9s is 18, then divide by the 9, so we get an x value of 2. So when we get down to here, we see that there's actually two turning points, which is right for a cubic equation. So in these two turning points then, one turning point has an x value of 0 and one turning point has an x value of 2. But if we look at the first question, it gave us one of these turning points already with this x value of 0. So I don't have to do this because I already know that turning point. The other turning point I have is where x is equal to 2. How do I find that? Because I need the actual coordinates, remember that. Well, to find coordinates, we always put the x value back into the original equation. So putting this x value of 2 into the original equation gives us f of 2. That's equal to, and I'm taking this stuff, 3 over 2 times 2 cubed minus 9 over 2 times 2 squared plus 2. That's 3 over 2, 2 cubed is 8, minus 9 over 2 times 4 plus 2. What's that going to be? 3/8 is 24 divided by 2 is 12. Minus 9 by 4 is minus 36 divided by 2 is that minus 18. And then plus 2. So I have 14 minus 18, which is going to give us a minus 4. So I put the x value in it too. I'll cut back the y value of 4. That means our other turning point is 2 and minus 4. That's it. Question done.